Hey everybody, this is Larry. This is day 30th. Wow, oh no, second to last. I can't, all 5-1 errors. This is what happens when you're programming. You have all 5-1 errors even on day. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today we have 1442. Count triplets that can form two arrays of equal XOR. Alright. Given an array of integer R, we want to select three indexes, I, J, and K, where I is less than J is wait, I could be this is a very awkward way of like there's a lot like certain things are equals and certain things are not, so I don't know. Okay. So J could be equal to K, but I don't what? Is that right? I guess so. Alright, let's actually finish up. Let's define A and B as follow. A is equal to some subset to J minus 1, and B is equal to subset J to K. Okay, that's why J could be equal to K, because this is just the same as one element, I suppose. And this has to be less than because... So basically, we're by partitioning, so we have I and K, and then we have something in the middle. Okay, we turn the number of triplets such that A is equal to B. Okay. N is equal to 300, so that makes it a little bit more tenable. Maybe I was trying to think about some hash table-y things, but with 300, right? So we cannot do so. This I, J, and K. If we naively iterate all three, that's 27 million. Maybe it runs in Java because apparently Java is fast for everything, but in Python we will not consider it. And I think there probably is a little bit smarter than that. Otherwise, it's not a medium. Maybe, I don't know. Leetcode is always weird, right? Okay, so then now we have to think, right? Let's because n is 300, we can say. Maybe we can iterate on two of them, right? Keep it n squared or n squared log n maybe is probably fine as well, but at least something like that. And then what would that look like? Well, there are really only three choices to iterate I, J, and K, right? You could do I and J and I and K and then whatever, right? I'm trying to think which one is easier. Well, okay. I think one thing that I forgot to think about is that, okay, we turn the number of triplets where I, J, and K, where A is equal to B, right? What does A is equal to B mean? So let's write it out. So A is equal to B means that A is equal to this thing, right? Is equal to this thing. And of course, what does this mean, right? This means that A XOR B is equal to 0, right? So, okay, so given that, then now if we iterate, yeah, then now from that we can probably do something that's a little bit I guess this doesn't actually add anything, right? Because if we do something like for J is in N, for K is in range of J, N, right? In this case, then we can and we have some XOR number already, so X is equal to 0. We XOR it with array of K, right? Then now this means that X is equal to from J to K, right? And then now all we have to do is figure out how many I's are there, right? And how does that even work? Man, my brain is just not working today. Sorry, friends. I feel like that's been happening a lot lately, but yeah. But yeah, it goes back to like this thing, right? Because I think one idea that I forgot to do is this idea of prefix sum, right? Because then another way of thinking about this, what is this, right? This is just equal to, so let's say we have from J to K. So we have this thing. What does this mean, right? So we do a prefix sum idea, then it is just going to be A sub 0, right? R sub J. Cannot find the J. Right? So this is the prefix sum. And then it's this minus, or not minus, but an XOR really. But an XOR minus, which is the same as XOR, I guess. Right? J minus 1, right? So is this XOR this gets you this, right? And then now the question is, man, maybe I'm doing the wrong thing. I feel like this is so hard for medium for me. I'm just having issues. Or maybe I'm doing it the wrong way. I don't know. Then now, so now we have this. And we're trying to find this part such that I mean, it's just all math. I mean, or like algebraic things, right? Because then now here we have this thing. I mean, I probably should have just written it out. I'm just being lazy and trying to do it in my head, right? So now we have this thing, and of course this thing is in prefix sum terms, just this thing. Minus this, right? Right? I'm probably doing it the hard way. I feel like that's what I'm trying to do in my head. Is like, why does this feel so hard? Right? So then now we're trying to find. So this number we are given, right? This is what we have. So then now we're trying to figure out this thing, where we know what this number is, right? We know what this number is, and we know what we're trying to find here. So then now we're trying to find the number of i's for which this is equal to. So okay, so this is, let's just say this is let's just rename this a little bit, right? So this is total So this is a formula for, I don't know, just say J total, right? I don't know, naming is hard. And this is, let's just use okay, fine. Sorry friends, I'm struggling today. So let's just say this is x for another x. This is y, right, is equal to this. We know what this is because this has to equal to this. So this is, let's just say this is z, right? So then now we're trying to find all y's, right? And we know that x XOR of z is equal to y. So then now we just have to find the number of times the prefix is equal to y. So that that means that that's the number of times of this is equal to this, and then we know that z is going to be the leftover, if you will. I think I'm saying this pretty poorly, to be honest. I'm just struggling today, right? Yeah, and then after we calculate all this, then now prefix is going to say, okay, now treat j as a future lookup for I. Oops. So then now prefix, we want to XOR it by XOR of j, right? And then f of prefix we increment by 1. So f of prefix is equal to and that's really the idea. I feel like I'm doing a terrible job explaining it, but so X is this thing, right? So then now I'm using this as a all right. Let's just call it current because right, and then current this thing has to be equal to Z, right? And we know Z, so this is Z. Okay, let's just call it Z. So then Z X, what is X? And yeah, and X is the prefix. So then now prefix X F of this, right? And that's really it. It's just very hard to do it if you're trying to be cute, I suppose. I don't know what I'm doing. Did I mess this up? I am just struggling today. Apparently I overcounted. I mean, I think what I think I have to be a little bit careful about. No, I mean I think this is right and this is right, but I think I handled the I's and the J's correctly, but clearly not, right? Well, this one should be, was it 5 choose 3, is it? No, 5 choose, it's not choose because J could you go to K, that's why. But why did we return more? Let's take a look real quick. What is this printing for? And also, I guess that's a little bit easier. Zero, zero. Is this right? So the prefix is going to be 0. So 0, 1. This is J, this is K. There's no way that's, I think I'm messing up something on a border condition. I thought I. Okay. Z is 1. That makes sense. Oh no, I'm looking at the wrong one. That's why. Okay, but 0, 1. J has to be bigger than I. So that means that J cannot be 0. I think that's what I'm messing up. Okay, how did I handle that case? I guess the no object. Okay, fine. So I mean, the easy way is just handling this I, but we have to process I is equal to 1, and that means that prefix of 0. And then f of prefix increment by 1, I think. Maybe that's good. I don't know. Really? One is 1. I mean, there's no way that's right. Oh no, I'm looking at the wrong one anyway. But prefix is 1. I guess you can't count. You don't count the no thing, so maybe that's why. Okay, we fixed it for you. Man, I am struggling today. I don't even know. I'm not confident about it today at all anymore. I mean, I think the idea is roughly right, but I think I'm just not being smart. All right. So 1, 2 should have a 1. 1, 2. Set should be 2. So why isn't this? What is prefix? Prefix is everything, right? 2. So then now this is this. What is this? How am I counting it? The prefix is 0 or to 0. I'm trying to basically standardize how I'm thinking in my head. I'm trying to think of the order, count order wise, but I'm trying to figure out how to handle the no set. I think that's basically the idea. And what does the no set really maps to on the I side? I think I'm like messing it up. And this kind of has it right for it, but then now it is not true for one other case. It's here 2 2 because 1 and 2. Okay. 2 2 prefix and is 1, so this is 1. The prefix is also 1. Right, so that's actually right. Okay, so 0 2 and then 2. Okay, the indexing is just very confusing to me. That's all. I mean, it's not confusingly written. It's just my head is not counting it right. 2 2 is one more. Okay, fine. 2 4. So yeah, okay. 2 4. This 1. That's fine. Maybe. No, I mean I don't see one here in the 4. So this one is wrong. Why is this wrong? 2 2 4. 1 2 6 and 7. 1 6 and 7. It's gonna be 0. Okay. The prefix is 1. This is 0. So then now we're trying to count the number of prefix that is 1, but it counts itself. So that's why it's overcounting. Because it is trying to find the non-empty set. So, okay. I see. Because then now the empty set is the entire prefix. Because this is equal to 0, it tries to find an empty set as the answer. So I'm kind of incrementing this incorrectly, maybe. Like it's a little bit early, I think, that's all. Because we have to do it in a way such that it enforces at least one element. I am curious about, I don't know why I'm struggling so much on this today. I feel like this is not that bad, but I am not being smart with the segments and off by ones and stuff like this. But what we need to do is this, I think, and that changes things just enough. Yeah, because it's a way. I mean, I knew that that's the way to do it, but I wasn't. I have to double think about that, have a think, because it's just kind of tricky to know that this is before. But the reason is because the flipping this is good enough is that now it changes the order of it, allowing it, forcing it to be one element. But I don't know. I felt like this is a trickier problem than 19 minutes is a little bit slow. How did I do it last time? I guess I did it last time just by, like I said, with C++, and it's just fast enough. And because this is back in the day when I was just using random things, and maybe that day I did C++, and it was fast enough. I didn't think about it. I guess 300 cube is fast enough in C++. Maybe it is in. Ooh, what did I do? And maybe it is even in. No, I mean it's only fast to 42%. So I don't know. So. Yeah, I mean I guess I didn't solve it last time either. Yeah, I mean I think this is. I mean, it's very, as you can see, even I struggle with getting this, but I think the concept is okay. It's just arithmetic. I think one way that you can think about it, even though it's not quite the same because XOR has different properties, is kind of just think, okay, go back a second, right? I know that the XOR stuff, like I said, is very confusing, but the way that I would maybe attack this problem in my head to get enough practice is just like write the same thing here, but instead of using XOR, just use addition, right? And what I mean by that is that instead of writing this, you have like, oh, what the? You just do something like this, right? And then now, let's say you're trying to do this problem, and yeah, and then now everything kind of follows in the same way. Because this is, if you just treat it with addition, then this minus this makes sense, right? And this minus this is equal to this makes sense in addition, right? And of course, in XOR, the subtraction is another XOR, which is why some of the things looks confusing. But this is how you get this number from J to K, and when we brute force on it, and the idea is just like playing around with the operations of XOR. But I think once you have that visualization, everything else falls into place, right? This is, you just treat it as two differences of prefix sum. Again, we know what because we have this, so we want this to equal to that. So then that's just how you get everything else, and that z is equal to x minus z is equal to y, and we have to try to figure out the number of prefix y's where this is true. So this would be subtraction, which for XOR is another XOR, right? And once you do that, that's pretty much most of the idea. And I think the way that I did it was okay, but I think the hard part was just that this is not the way that I usually. I think the hard part for this is that that I kind of was a little bit lazy about, and I didn't think it through, and that's why I had to think it through a little bit later on, is that we have to force the I part to have at least one element. Because if I have done it the other way, then it just forces it to have 0 or more elements, which is why I was overcounting. And even here, as long as after we adjust this, it's fine. And actually, I think now that I handled that correct, I don't think I need this anymore. It just does nothing in the first iteration, to be honest, because this is all empty. Because prefix, I think so anyway, I could be wrong. Let's give it a spin. Yeah, okay, yeah. Yeah, because F is empty until, we go here. But yeah, this is a good practice problem. Definitely play around with it. The XOR problem makes it a little bit awkward for interviews, if you ask me. I don't know. I don't usually get many bitwise or XOR operations on interviews, but I could be wrong. I'm a little bit old. But yeah, but again, once you treat it like you would treat it with an addition and all these prefix sum, it kind of comes together. Yeah. Anyway, that's all I have for this one. Let me know what you think. I'm just taking a look at my Discord, and apparently most people did it with the IJNK, which is a little bit awkward. Or like, I mean, I guess it's fine. But yeah, I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. I'll do a bonus problem after this, so stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.